anything from designer to UX to product owner, and for the last 5 or 6 years as a software developer, mainly with PyCode as a backend engineer and also a data engineer. So the premise of this talk is that there's this analogy that growing a code base is like raising a kid, in that the parents need to be mature, they need to focus and pay attention to the code base, the kid, regularly, and that it's more of an art than science, and unfortunately the more coded parts or formalized parts of our trade are not very scientific, they're controversial. So now I have a couple of questions. Can you raise your hands? I would like to know which one of you guys are developers. Okay, so that's like everyone. And which one of you guys are developers and have children? Okay, so the good news for those of you who don't have children is that you kind of have some taste of how hard it is to raise children, because we deal with code bases a lot. And for those of you who have children, those two guys and me myself included, basically we're dealing with kids even when we're not home. So I'm going to give you a more realistic example of this analogy. So meet Stanisław, Stan. He is a kid that was raised without much love and attention, and as he got older it became very hard to control him, and at some point he just showed the middle finger to his parents when they tried to control him. So this is what we say, what we call niegrzeczny. So I've actually worked with a software equivalent of Stan. So this was a company that was founded like 12 years ago, and it was the baby of 3 co-founders. That's what they call it, the software they made. So it was the backbone of their business, and what it did was pretty simple. And when I joined the company though, it was several years into their founding. So they had more customers, and as they gained more customers, they had to add more features to the code base. And now they call their baby the mother. As you can see, it does quite a few things: machine learning, back-end, front-end code, talks to several APIs, external services, and basically we knew what the problem was. We knew the bugs. The bugs were costing us millions of euros every year, and we knew exactly how much effort we would have to put into this to fix it, but we never did. And worst of all, when we needed a similar system, we just cloned this one. So if you're an experienced developer, you're probably familiar with some best practices for how you can raise a code base so it's not a mess. But we usually work in teams, and sometimes there are people in the team who don't agree with you. And so the analogy of this would be that you're like divorced parents trying to raise Stanisław, and you don't agree on how he should be raised. So one of you is like teaching him, don't eat sweets before dinner the whole week, and Stan goes to his other parent during weekend, and all he eats is like cookies throughout the day. So you see where that issue is. It's not just like, oh, I know solid principles, I know clean code, blah, 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 design patterns. If you have guys in the team who don't, or don't care, then that's a problem. At the company level, if you worked in bigger companies, you've probably seen this and felt this way. If you say neglected software is like an orphan, then basically the tech department is an orphanage. And the problem is that these orphans are in charge of the backbone of the business. So I've mentioned that we have some best practices, but how useful are they really? That was probably me when I learned about these things in a short period of time. But let me give you a clear example. So let's say Agile. I follow one of the founding authors of the Agile Manifesto on Twitter, and basically he spends almost all day telling people, this is not Agile, that's not Agile. It should be like this, but no, that's not good. And there's like something called fake Agile, there's another thing called dark Agile. And it's just, but this is really sad because Agile is supposed to be one of the best things we've come up with in our trade, in our history. But it's not clear what it is. Why is it that most of us are wrong about Agile? Is it that we are too stupid, or is it that the problem is Agile itself, the way it was formulated? To be fair, we've made some progress. So things like TDD are pretty clear, what they mean. Clean code also, or the clean series. But compared to how long we've been parenting kids, if we want to push that analogy, we're like 5-year-old children trying to raise other children, just because our industry is so young. So my point here is that it still is much more of an art to raise a good code base, just like parenting is. So if you read books on parenting, you would see very similarities. There's really no agreement on what's the way to do it, or the best way. So I mentioned these best practices already. The issue I see with them is that each of them sees the problem from their own point of view. That's why you have conflicts between the adherence to each of these philosophies, let's say. There's conflicts, there's like object-oriented is the best, or no, functional, now I've heard in the JavaScript word functional is like, the top trend. Is it true or not? Yeah? So, but a while ago it was like object-oriented, that's why they had TypeScript or whatever. But, so it's not like, you learn these things and you're like, okay, now I know everything. No, it's more like you have a puzzle, there's pieces in the puzzle that you need to put together, and also there's pieces that I think are missing. So we'll get to that later. And another thing is that there's really no consistent way of applying these guidelines. So if you introduce one of these best practices to your code review process, you end up with a very prolonged process. You introduce many conflicts, so people don't agree on the size of the function, or the naming of the functions, or the naming of your tests. And so this is one of the reasons I think something is missing. And I think what's missing is that holistic view of software development. So let me summarize. We need to pay regular attention and focus regularly on raising our code bases. We usually need to do that in teams with more than 2 developers or parents. And this process is more of an art, so you can't just follow the rules and you're done. And the more scientific parts of our trade are controversial, so they're not, they're controversial. So the first thing, well, I've come up with a list of solutions, so this is not comprehensive, it's just based on what I've learned and experienced. And I'm going to start with what you can do as an individual. That's the easiest place to start. And so the first thing is, as a parent, most parents know that what you don't want to do is ignore the kid, because that's the worst thing you can do. So as developers, it's basically, don't do that. Like whatever you do, don't ignore it. Because as time goes by, it gets harder and harder, and at some point, it just becomes impossible. So start as early as possible. So let's assume that you have learned these, or you're familiar with these best practices. So when do you apply them? The rule is in every commit, you need to make them basically adopt them as a skill set, and don't think of them as this is a refactoring task I'm going to do later. So my first solution is going to be ugly. I'll fix it later. That later usually never comes. Like if you worked in busy teams, you usually see in the backlog there's like 100 refactoring tasks, and usually they're never put into the sprint. So the best way to go is to go slow, especially in the beginning when you learn these things. It takes time, and maybe one of the issues is like, how about deadlines? Or tell your boss that you can't make it to the deadline. Business people usually don't get these things. So if you just say it's not possible, then it's not possible. They're not going to be like, well, you wrote 2 more tests and it took you 2 more days or whatever. That's not going to happen, unless your boss is a developer also. But in the beginning, yeah, it's hard to estimate tasks. It will take time, but they just become part of who you are, these best practices. You become a better developer, and when you estimate, you have this in mind. So maybe for a few sprints, your estimates are off more than usual, but it goes back to normal pretty quickly. So another thing that I've seen is that people adopt new technologies, so they add a new library or framework or whatever to a stable project, or they start the project with a new framework or whatever. And this is something in our industry. We have these trends. The cycle of trends is shorter than other industries, I would say. And this is one of the worst things you can do, because the design patterns for integrating these libraries, these new tools, is not clear, usually for years. So it takes years and years of people trying, experimenting, changing the code base, changing the API, the signatures of the main interfaces of these tools. It takes some time, usually years, so they become stable. And you don't want to be part of that experimentation if you're putting that code into your production system. So my rule of thumb is whatever new thing I want to put into a stable system, it has to be at least an order of magnitude better than what I already have. So that's like at least 10 times. It served me well. So I can give you an example of async I/O. We had a requirement basically for having an async backend. And the choice was to either go with async I/O or JavaScript or Go. And as a Python developer, I chose async I/O. This was last year. And async I/O was already several years into making. They introduced it, I think, more than 5 years ago. And if you think about Tornado and Twisted, it's probably 20 years old in Python. But I would usually get stuck in debugging stuff, like I would put a breakpoint, and as I'm going to the next one, it just jumps and goes into like the heart of the loop, the event loop, and you just like, next, just go jump here, jump here. It's like a totally different, let's say, paradigm of programming, and it pissed me off. It pissed my manager off. Then when it comes to testing, oh my God! Now you have to create your own mocks, create your own doubles. There's bugs because it's async. It's not just you can use the sorry for the noise, the unit test library. The libraries that talk to the database, they need to come up with testing utilities. Do they come with them? Well, not usually, unless they're pretty mature libraries. So yeah, avoid that as much as you can. So what if you already have some legacy code or a ball of mud that you want to get rid of? What I've learned for justifying such efforts is to create some, or measure the impact and make them visible, so create some metrics. So I usually show this to developers as like hours a week we spend just waiting for the test to run in Jenkins or whatever on GitHub, and the amount of context switching it causes when you push your code and you need 45 minutes to get the feedback. For the business people, usually I show them, you know, we couldn't do these 3 features because we were just waiting for the test, you know. So we may have lost $10,000 a month because we lost those 2 users who wanted that feature, but we never got around to doing it. We were waiting for 6 months. So you need to make this such a document and make it visible to be able to justify your refactoring efforts. Now I'm going to move on to the team sport part of the solutions. So this is inevitable. Yeah, we work in teams. And what do you do when you work with more than 2 people in a team? So when you have more than 2 parents? The first thing I think is to minimize the number of parents. You do this for 2 reasons. First of all, if you do have bad parents, you want to minimize their impact. So you want to isolate them. Like, you know, the market situation in our industry kind of doesn't allow most people to get rid of bad people. So what you don't want to do is put them in a big team, because then, you know, yeah, good luck. So, yeah, so, you know, have a 1 team project code base and be like, hey, dude, hey, ninja, you know, coder, you can have this project, just be a ninja with it, whatever, you know. The other thing is that, as a rule of thumb, smaller teams create higher quality code bases. Obviously, open source is an exception, but that's a totally different scenario. So the next thing is, when you join a team or you hire someone, you want to make sure they're open. So openness is actually a big 5 personality trait, and it means how much effort it takes to for people to think about new things or consider it even. So I'm sure you've probably met people who are just like, no, I don't want to hear it. I don't care. No. It doesn't matter. It could be politics, religion, technology. It just doesn't matter really. It's just a personality trait, and some people are high in openness, some people are low in openness. And I rather work with people who are high in openness, because that's how I am. And, you know, I'm constantly thinking about new crazy ideas, and, you know, the other poor guy, he better not sit next to me because he'll go crazy, right? Or I will go crazy. So the other thing is, you want to work with mature people. Unfortunately, you know, we have these kids who start coding when they're 9, so then they get their first senior developer job when they're 11. And so, you know, you leave a comment on their code and they just get wet, and like, they think you're insulting, you know, their parents or the core of who they are, because, hey, you could improve the name of this variable, you know? And I'm sure some people have seen these people. It's best to ignore them, you know, let other people raise them, or, you know, just wait for them to get older and become more mature. So the next thing is, if you're a tech lead, or if you're brave enough that you want to influence your team and say, hey guys, you know, there is a better place we could go to, then that requires leadership skills. And this for me was one of the hard things to learn. People are not just going to follow your lead, no matter how much they act like computers. So even if you've been programming for 50 years, yeah, you're not that logical. So I studied in business school, and that's where I was supposed to learn leadership skills. That's why I never learned it there. And I always thought it's for people in business suits. Well, if you are right, if what you say makes sense, why would anyone else not follow it or not do it? Yeah, that's not how it works. It never works that way. So as a product owner, I can give you an example that I worked with designers, marketing people, sales people, management, junior developers, senior developers, and no one was more logical than the others. Just logic was like less than 1% of their brain, it seems like. And we're not built that way. Like if you study how the brain works, we're not computers. That's why we trust computers, actually, because they don't have our brain. They don't have emotions. They don't have that mammal or what do you call it? The deep part of the brain that detects like danger or whatever. So there are many resources. Most of it I don't recommend. The one I do recommend that I found like very recently is from a guy that he was commander in the Navy SEALs, and so he was part of really badass missions. And he actually, I always thought in the military it's like, go do this, and the soldiers were like, yeah, we're gonna like do it. But it's not like that, actually. What he was explaining is that leadership in such situations is much, much harder than in like, leading developers or whatever. So I liked his way because it was just a no-nonsense, explanation of motivations, of people who work under you, how they feel, why they don't listen to you, why do they follow you if they do. That's what I recommend. You're free to come up with your own sources if you want. So now moving on to the last group of solutions. I think the reason why we are so confused in our industry is because we have much more art than science. I've said this many times already. So the question is why? And I think the answer is that people jump in and they want to do. Yeah, they're like, I learned Python and now I want to make a website. And so we don't get to ask such questions. What do we do as programmers? Like this is, you hear this, yeah, all the time. And it's like, well, we open the editor, we write some text, and we run it, and there's like the stack trace, there's color formatting, and what skills are necessary? Well, you need to be able to think like a computer, logic. It took me years actually to come up with answers for these questions, and it takes you to weird places. And I think what other engineering practices have figured out is, you need to teach people some things. Like, you can build a bridge 1,000,000 times. You're just not going to come up with basic laws of physics unless you're Newton or Elon Musk. And we need to have that. Like, it's not bad to have some theory in the beginning, or in the middle after a few years, you're coding your web apps. Maybe it's worth it to look at these questions. So I invite people to actually ask these totally non-practical questions, totally philosophical questions, and I think it puts you in a different level. Like, the more you think about what we do as programmers, like actually sit down and write. Am I writing code? Am I just writing? Is it like writing a book? Writing a program. Is it like writing a book? Maybe, but not totally. What is it then? I think in the domain-driven development terminology, they say we create domains, like in our languages, and these domains mirror the business domain. Yeah? So what is that? Are we like business analysts, plus we are writers, plus we have, we're mathematicians, we write algorithms also? Yeah? So what skills do we need to have to be good developers? So the next thing is, if you go to this link, I put some sample document there. This is like a developer's oath. There's actually books written about this. Uncle Bob has written a book about this. And this is, I linked this page on my CV. And I say, at the top of my CV, I say, these are the rules I abide by. So I try every day to follow these rules. And these are the absolute minimum requirements, in my opinion, to have somebody in a professional team. Okay, so they're juniors, okay, but show them at least a document. Yeah. But you can read, you can start learning, but at least know what's required. Yeah. So when you interview someone, you can ask them, do you agree with these things? Are you familiar with best practices? Do you want to debate it? If not, do you even care? And from my experience, only one person ever mentioned this, so they actually clicked through the link and went there and read what I had on GitHub. And that's, in my opinion, that's not a good sign. I don't know. That means I should have only one employer so far, but I have more. So I broke my own rules. So the last slide is, there's a lot of books about these things written. I found only 2 sets of comprehensive ideas that cover most of what I said. So there's the Clean series from Uncle Bob, and the latest entry was Clean Agile. I think that makes the Clean series the most comprehensive set of ideas we have so far. I wish we had more, but there's at least one. You can get started today if you want to. And there is also the extreme programming methodology, which is 25 years old, I guess. That's also pretty comprehensive. And with that, I would like to bring or finish the speech, the presentation. Good luck.